Hello everyone, myself Sindhuja. I'm from branch EC and my roll number is 23401A04A7, and today's my topic is on introduction to noise in communication systems, and I took the topic from the subject analog and digital communication, and the subject code is the 23ECE403. And let us know what is mean by noise and how does it works in communication systems. Let us know what is mean by noise. In communication systems, noise refers to any unwanted electrical or electromagnetic interference that distorts or disrupts the original signal during the transmission, reception, or processing. Noise can degrade the quality of communication, leading to errors and misinterpretations of the transmitted message. Uh, the correct definitions of the noise is that noise disturb the proper reception and reproduction of transmitted signals, or else we can say that noise is unwanted electrical disturbance which gives rise to audible or visual disturbances in the communication systems and errors in the digital communications. uh, Let us know the sources of noise. Sources of noise is of three types: natural source of noise, man-made source of noise, and fundamental source of noise. Let us know the in detail about these sources of noise. uh, Natural source of noise: the noise originating from the sun and the outer space is known as extraterrestrial noise. The extraterrestrial noise is of two types: solar noise and cosmic noise. When it comes to solar noise, it is generated by the sun. When it comes to cosmic noise, it is generated by the stars, for example electronic storms and solar flare, etc. Second one, man-made sources of noise. The man-made noise is generated due to the make and break process in a current carrying circuit. Man-made source of noise is also known as industrial noise. Example electrical motors, welding machines, switching gears, etc. Fundamental sources of noise: the fundamental source of noise or within electronic equipment, they are called fundamental source because they are integral part of the physical nature of the material used for making electronic components. Example thermal noise, short noise, atmospheric noise, etc. Fundamental sources of noise is also known as internal source of noise. When now we have completed what are sources of the noise, and let us know types of noise. There are five types of noise: thermal noise, partition noise, short noise, high frequency noise, and the low frequency noise. Let us know classifications of noise, which is of the five types. When it comes to the thermal noise, the free electrons within a conductor are always random motion. This random motion is due to the thermal energy received by them. The distribution of these free electrons within a conductor at a given instant of time is not uniform. It is possible that an excess number of electrons may appear at one end or the other of the conductor. The average voltage resulting from this non-uniform distribution is zero, but the average power is not zero for the non-uniform distribution. At this power results from the thermal energy, it is called as thermal noise power. The average thermal noise power is given by P fix n is equals to k dp watts, where K is Boltzmann's constant and its value is 1.38 into 10 to the power of minus 23 joules per Kelvin. B is known as bandwidth of the noise spectrum. It is measured in hertz, and T is temperature of the conductor, units Kelvin. Thermal noise is also known as Johnson noise. Partition noise. Partition noise is generated when the current gets divided between two or more paths. It is generated due to the random fluctuations in the division. Therefore, the partition or noise in a transistor will higher than in a diode. The devices like gallium arsenide FET draw almost zero gate bias current, therefore keeping the partition noise to its minimum value. Short noise, it arises due to the short effect. It is produced in all amplified devices rather than all active devices. Short noise can be calculated by using the diodes. Ln power 2 is equals to 2 into 1 plus 2 ln into QB ampere square when I equals to direct where I is equals to direct current across the junction. In it is measured in amperes. L naught is equal I naught is equals to reverse saturation current in amperes. Q is equals to electronic charge as it values 1.6 into 10 to the power of minus 19 Celsius. B is equals to effective noise bandwidth in hertz. For the amplifying devices, the short noise is inversely proportional to transconductance of the device, directly proportional to the output current. When it comes to low frequency is also known as flicker noise. It arises due to the flicker noise will appear at frequencies below a few kilohertz. It is sometimes called as 1 by f noise. The mean square value of flicker noise voltage is proportional to the square of direct current flowing through the device. The fifth one is that high frequency noise, or else it is called as transit time noise, or else it is called as transient noise. If the time taken by an electron to travel from the emitter to the collector of a transmitter become comparable to the period of signal which is being amplified, then the transit time effect takes place. This effect is observed at very high frequencies. Due to the transit time effect, some of the carrier may diffuse back to the emitter. This gives rise to an input admittance, the conductance components of which increases the frequency. The minute current induced in the input of the device by the random fluctuations in the output current will create random noise at high frequencies. Once the noise appears, it goes on increasing with frequency at a rate of 6 dB per octave. The causes of noise is that noise can be originate from various sources, broadly categorized into external noise generated outside the communication system, atmospheric noise caused by natural sources like thunderstorms and lightning, man-made noise generated by humans' activities such as electrical appliances, machinery, and radio transmissions. Extraterrestrial noise comes from cosmic sources, including solar radiation and space based interference. Internal noise generated within communication system. Thermal noise caused by the random motion of electrons in electronic components. Short noise results from the random movement of charge carriers in semiconductor devices. Flicker noise occurs at low frequencies in electronic components. Effects of noise. Noise affects communication in various ways, including signal distortions, alters the shape and quality of transmitted signal, reduce signal to noise ratio. Signal to noise ratio, simply represented as SNR, makes it harder to distinguish the original signal from noise. Data errors causes incorrect interpretation of digital or analog signal, leading to communication failures. Reduced system performance, lowers and the efficiency and reliability of the communication networks. And final conclusion on noise in communication system. Noise is unavoidable accept of communication system originating both external and internal sources. It can be degrade signal quality, cause data errors, reduce system efficiency, and understanding the different types of noise such as thermal, short, flicker, atmospheric noise helps in designing effective noise reduction techniques. To minimize its impacts, engineers use methods like filtering, shielding, error correction, and signal amplification. While noise cannot be entirely eliminated, proper system design and advanced technologies can significantly improve the reliability and performance of the communication system. Thank you.